Hello students, now I am going to discuss about the clock and oscillator. So clock and communication purpose actually we are going to use. It may be a ceramic or crystal, and we have to create some pulses with the help of this clock. So we are divided two pulses. Two pulses created one state. Six states create one machine cycle. Sometime one, sometime two, or sometime four machine cycle create one instruction cycle. Like that, if two pulses create one state, six state create one machine cycle. Sometimes one machine cycle, two machine cycle, or four machine cycle create one instruction cycle. As per this timings, address latch will be going high and going low. When it is going high, address bus will be activate. When it is going low, data bus will be activated. So time to execute an instruction is how much time is needed to execute one instruction. It is the formula is C into 12 by F. F is crystal frequency. What type of crystals we are going to use? This frequency of the crystal provided F. C into 12 by F. What is C? C is the number of cycles of the instruction. So how many cycles are there? How many machine cycles are there in the instruction? It will be multiply with 12 by F. This is the formula. Next, timer and counters, event detection, time control, signal generation is the main work provided by timers and counter. Reads from or written to be the processor and is given by some constant frequency source. Generates an interrupt at the overflow run by microcontroller clock or external clock. So this is the purpose of counter. Intervals, how can I be measure? Counter maximum counting time minus reloaded time by clock frequency. This is the formula. Next, timers and counter. What I told you, timers are very much important part of the 8051 microcontroller. A machine cycle instruction lasts for 12 quartz oscillator periods, which means that by embedding quartz with oscillator frequency of 12 megahertz and numbers stored in the timer register will be changed million times per second. That is each microsecond. So two timers are actually we are going to use. It will be T0. Already I discussed this thing during the architecture. And T1. In T0 timer, it is a 16-bit timer divided into two registers, TL0 for lower bits and TH0 for higher register bit. If the timer contains, for example, number 10000 decimal, then TH0 register high byte will be contain the number 3, while the TL0 register low byte will contain decimal number 232. So this is the formula. So T80 into 256 plus TL0 equal to T. That means total time. So this is my total 100. 3 will be into 256 plus 232. So how can I able to find it? T80 equal to 1000 because my decimal number is 1000. That is 100 by 256. That means 3. I can able to find this number 3 like that. Same thing when I able to find the TL0. Same thing, my decimal number is 1000. Suppose this number I have to contain in the timer. So 1000 minus 3 into 256. So I can able to find 232. So these two binary numbers I have to, it will be come into the TH0 and TL0. Okay. So this is the timer. So largest value it can store is 65535. In case of exceeding this value, the timer will be automatically cleared and countering starts from 0. This condition is called an overflow. Next, T mode register, timer mode register. That means which mode of the timer I am going to set or reset. It is decided by this T mode register. So T mode register is there are 4 operational mode. So the bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, and bit 7. So this first is there in this T mode register. The lower 4 bits, that means bit 0 to bit 3 refer to the timer 0, while the higher 4 bit 4 to bit 7 are referred to the timer 1. So gate 1, that means what the gate is the gate. Gate 1 enables and disables timer 1 by means of signal brought to the INT1 pin 3.3. If it is a 1, timer 1 operates only if the interrupt 1 bit is set. If it is 0, timer 1 operates regardlessly of the logic state of interrupt 1 bit. Same thing, C/T1, that means this bit. Select pulses to be counted up by the timer 1. If it is 1, timer count pulses brought to the T1 pin. If it is 0, timer count pulses from internal oscillator. And timer TIM1 and TIM0, these two bits select the operational mode of the timer 1. What mode it will actually going to operate? It is decided by this 2 bit. If T1M0 is 0, and T1 M1 is 0, it will be good for mode 0. If both are, if T1 M0 is 1, T1 M1 is 0, it will be mode 1. In mode 0, the timer will be treated as a 13-bit timer. And mode 1, the timer will be a 16-bit timer. And when T1 M0 is 0, T1 M1 is 1, in that time it will be mode 2. Timer will be 8-bit auto reloaded. That means one 8-bit count will be complete, another 8-bit will be come. Like that it will be count. And both the 1 1, in that time it is called mode 3. In that time it is called split mode. Split mode means the two 8-bit timer will be working independently. This is split. Mode will be split. Okay. So same thing will happen. The timer 0 also. Okay. The first, this is the mode 0. First, both timer 0 and timer 1, both mode 0, mode 1, mode 2 and mode 3, all are same. So this mode, that means the mode 0, this mode configures timer 0 as a 13-bit timer, which consists of all 8 bits of TH0 and lower 5 bits of TL0. As a result, the timer 0 uses only 13 of 16 bits. Each coming pulse causes the lower register bits to change their states. After receiving 32 pulses, this register is loaded and automatically cleared. While the higher bit TH0 is incremented by 1, this process is repeated until registers count up 8192 pulses. That means 8192 pulses. After that, both registers are cleared and counting starts from 0. Okay. Next, timer 0 or 1. Both timers mode is same actually. In mode 1, in that time it will be 16-bit timer. Mode 1 configures timer 0 as a 16-bit timer comprising all the bits of both registers TH0 and TL0. That's why this is one of the most commonly used modes. Timer operates in the same way as in mode 0, with difference that the register count up to 65,536 as allowable by the 16 bits. So in that time, in this mode 1, it will be treated as a 16-bit timer. Next, auto reloaded timer. That means mode 2. Mode 2 configures timer 0 as an 8-bit timer. Actually, timer 0 uses only one 8-bit register for counting and never counts from 0, but from an arbitrary value 0 to 255 stored in another TH0 register. That means it will be first, suppose it will be count, after that it will be another TL0 it will count, like that it will be happening. Split timer modes configure timer 0 so that register TL0 and TH0 operate as a separate 8-bit timers. Both are separate actually. In other words, the 16-bit timer consists of two registers TH0 and TL0 is split into two independent 8-bit timers. This is the called split timer, like that. Both are independent. It will be count separate, it will be count separate. Previously, what happened? It will count, after that it will be transferred in, suppose, no, sorry. TL0 is count and it will be transferred into TH0. But now in mode 3, both are independent timer. So it is all about the T mode register. In the next session, we are going to discuss about the T-con register. Thank you.